On July 20th, 1969, roughly 600 million people, nearly a fifth of the entire population of planet Earth at the time, gathered around television sets to watch a grainy, ghostly black and white image of a man in a bulky white suit climbing down a ladder and stepping onto the surface of another world. It was the culmination of a decade long, almost unimaginably difficult national effort, built on the deaths of astronauts, the labor of hundreds of thousands of engineers, and a promise made by a young president who would not live to see it fulfilled. This is the story of Apollo 11, the mission that put the first human footprints on the moon. To understand how humanity reached the moon in 1969, you have to go back to the anxious competitive atmosphere of the Cold War, and specifically to October 4th, 1957, when the Soviet Union launched Sputnik, the first artificial satellite ever placed into orbit around the Earth. Sputnik's success stunned the American public and government alike, sparking a wave of anxiety that the United States was falling dangerously behind the Soviet Union in science, technology, and most alarmingly, in the military implications of rocket technology capable of placing objects and potentially weapons into orbit. This anxiety only deepened in April 1961, when Soviet cosmonaut Yuri Gagarin became the first human being to travel into space and orbit the Earth, another decisive Soviet first that left American officials searching for a way to definitively overtake their rival in the increasingly public contest that had become known as the space race. It was in this charged atmosphere that President John F. Kennedy, in a speech before a joint session of Congress on May 25th, 1961, just weeks after Gagarin's flight, and shortly after the disappointing failure of the American-backed Bay of Pigs invasion of Cuba, made an extraordinary, and to many experts at the time, almost recklessly ambitious commitment, declaring that the United States should commit itself to achieving the goal before the decade was out of landing a man on the moon and returning him safely to the Earth. Kennedy would restate and expand on this commitment in a now famous speech at Rice University in Houston in September 1962, telling the assembled crowd that the nation chose to go to the moon, not because it was easy, but because it was hard, framing the effort as a test of the nation's collective skill and energy, and implicitly a demonstration to the world of the superiority of American, and by extension democratic, and capitalist achievement over that of the Soviet Union. Achieving this goal required an effort of staggering scale, ultimately involving, at its peak, some 400,000 engineers, scientists, and technicians working across NASA and its network of private contractors and university partners, and consuming, over the course of the decade, roughly $25 billion of the era, a sum that would translate to well over $150 billion in modern terms, representing at its height several percent of the entire United States federal budget dedicated to a single scientific and engineering endeavor. NASA pursued this goal through a series of preparatory programs: Project Mercury, which put the first American astronauts into space and orbit during the early 1960s, and Project Gemini, which ran through the middle of the decade and developed critical techniques, including spacewalks and the orbital rendezvous, and docking maneuvers that would prove absolutely essential to the lunar landing missions that followed. The Apollo program itself suffered a devastating early setback that nearly derailed the entire effort. On January 27, 1967, during a routine ground test of the Apollo 1 spacecraft at Cape Kennedy in Florida, a flash fire swept through the command module's pure oxygen atmosphere, killing all three astronauts aboard: Gus Grissom, one of the original Mercury 7 astronauts and a veteran of both Mercury and Gemini flights; Ed White, the first American to walk in space; and Roger Chaffee, a rookie preparing for his first spaceflight. The tragedy forced NASA into a lengthy period of investigation and redesign, addressing serious flaws in the spacecraft's wiring, materials, and hatch design that had contributed to the fire and made escape impossible for the trapped crew, delays that pushed the program's timeline back by roughly a year and a half, but that many engineers and historians later credited with making the eventual lunar missions considerably safer than they otherwise might have been. By 1969, NASA had worked through a careful, escalating sequence of Apollo test missions, from Apollo 7's crucial first crewed test of the command module in October 1968 to the daring Apollo 8 mission in December of that same year, which became the first crewed spacecraft to leave Earth orbit entirely and travel to the moon, with its crew, including astronaut Frank Borman, famously reading passages from the Book of Genesis in a live broadcast on Christmas Eve while orbiting the lunar surface, to Apollo 9 and Apollo 10, which tested the lunar module, the specialized spacecraft designed to actually land on the moon's surface, in Earth orbit and then in lunar orbit, respectively, essentially rehearsing every step of a landing mission except the landing itself. By the time Apollo 11 was assigned its historic task, the individual pieces of the mission had each already been tested and proven. What remained was to put them all together for the first time, for real. The three astronauts selected for the Apollo 11 mission were Neil Armstrong, Buzz Aldrin, and Michael Collins, each bringing a distinct background and temperament to the historic flight. Neil Armstrong, the mission's commander, was a former naval aviator who had flown combat missions during the Korean War before becoming a test pilot, flying the exceptionally dangerous X-15 rocket plane at the edge of space, and had already flown in space once before, commanding the Gemini 8 mission in 1966, during which he successfully managed a dangerous in-flight emergency, a stuck thruster that sent the spacecraft into an uncontrollable spin, through calm and decisive action that helped establish his reputation within NASA as an unusually cool-headed pilot under extreme pressure, a reputation that factored significantly into his selection to command the first landing attempt. Buzz Aldrin, the lunar module pilot who would become the second human being to walk on the moon, held a doctorate in astronautics from the Massachusetts Institute of Technology, with a thesis specifically focused on orbital rendezvous techniques, making him, in a very real sense, one of the most technically qualified individuals in the entire astronaut corps for the specific challenges the mission would present. And he had already demonstrated considerable skill during his own Gemini 12 mission in 1966, successfully completing a lengthy and technically demanding spacewalk that helped solve problems that had plagued earlier American spacewalking attempts. Michael Collins, the command module pilot, would remain in lunar orbit throughout the moonwalk itself, piloting the command module Columbia alone around the moon, while his crewmates descended to the surface below, a role that placed him, during periods when his orbital path took him behind the far side of the moon, more completely isolated from any other human being than any person in history up to that point, entirely cut off from radio contact with both his crewmates on the surface and mission control back on Earth. Crashed during a 1968 training flight, an incident he survived without serious injury, and according to colleagues, discussed so calmly back at the office afterward that many did not initially realize how close he had come to death. Preparing the crew for the mission itself involved years of exhaustive and often physically grueling training, including thousands of hours spent in flight simulators replicating every conceivable phase of the mission and its potential failures, extensive geology field training in volcanic terrain in places like Hawaii and Arizona meant to approximate lunar landscapes, and countless hours practicing in a specially modified helicopter known as the Lunar Landing Training Vehicle, an infamously difficult and dangerous machine that Armstrong himself was forced to eject from moments before a crash during a 1968 training flight, an incident he survived without serious injury and, according to colleagues, discussed so calmly back at the office afterward that many did not initially realize how close he had come to death. Apollo 11 launched from Kennedy Space Center in Florida on July 16, 1969, atop a Saturn V rocket, still, to this day, the most powerful machine ever successfully built and flown by human beings, standing over 360 feet tall and generating some 7.5 million pounds of thrust at liftoff, watched in person by an estimated 1 million spectators gathered along the Florida coastline, and by a global television audience numbering in the hundreds of millions. The spacecraft's journey to the moon took just over 3 days, during which the crew performed a critical maneuver, transposition and docking, separating the command module Columbia from the spent third stage of the rocket, turning around and docking nose-to-nose with the lunar module Eagle, still nestled within the rocket's upper stage, before extracting it for the remainder of the journey. On July 19, the spacecraft entered orbit around the moon, and on the morning of July 20, 1969, Armstrong and Aldrin entered the lunar module Eagle, separated from Collins and the command module Columbia, and began their historic descent toward the lunar surface, a maneuver that would prove to be one of the most tense and technically fraught episodes of the entire mission. Overseeing the entire descent from the ground was the mission control team in Houston, led by Flight Director Gene Kranz, whose white team of controllers had trained extensively for exactly this kind of high pressure, split second decision making. A culture of rigorous preparation and calm professionalism under pressure that Kranz himself had worked deliberately to instill in the wake of the Apollo 1 fire 2 years earlier, when he had famously told his team that mission control would from that point forward be tough and competent in equal measure, never again allowing complacency to compromise a mission or a crew's safety. As the lunar module descended, its guidance computer began triggering a series of alarms designated 1202 and later 1201, indicating the computer was becoming overloaded with more data than it could process in the allotted time, a genuinely alarming development that forced a rapid, high-pressure judgment call from a young guidance officer in mission control named Steve Bales, working alongside backroom support from software engineer Jack Garman, who quickly determined that the alarms, while concerning, did not necessarily indicate a mission-ending failure and gave the crucial go-ahead for the descent to continue, a decision credited with saving the landing that day. As if the computer alarms were not tension enough, Armstrong, looking out the lunar module's window during the final phase of descent, realized that the spacecraft's automatic guidance system was steering the Eagle directly toward a boulder-strewn crater that made for an extremely hazardous landing site. With fuel supplies dwindling toward a critical minimum and mission control back in Houston tracking the situation with mounting anxiety, Armstrong took semi-manual control of the spacecraft, flying it further downrange in search of a safer landing spot, an improvised piece of piloting under extraordinary pressure that used up nearly all of the lunar module's remaining fuel margin before Armstrong finally identified and settled the spacecraft onto a relatively flat, clear patch of lunar terrain, with, according to later analysis, somewhere between 15 and 25 seconds of fuel remaining before the mission would have required an abort. At 4:17 p.m. Eastern Time on July 20th, 1969, Armstrong radioed back to Mission Control the words that confirmed the successful landing. Houston Tranquility Base here. The Eagle has landed. A transmission that prompted an audible and enormous release of tension among the flight controllers in Houston, several of whom, according to numerous later accounts, had been holding their breath through the final harrowing seconds of the descent. The name Tranquility Base referred to the Sea of Tranquility, the lunar plain selected as the mission's landing site. Following the landing, Armstrong and Aldrin were originally scheduled for a rest period before venturing outside, but keenly aware of the historic significance of the moment and eager to proceed, requested and received permission to move up the moonwalk instead. After several hours spent preparing their spacesuits and depressurizing the lunar module's cabin, Neil Armstrong opened the hatch and began climbing down the ladder attached to the lunar module's leg. A descent broadcast live to the enormous global television audience via a camera mounted on the spacecraft, and at 10:56 p.m. Eastern Time, Armstrong stepped off the ladder's final rung and onto the powdery surface of the moon, becoming the first human being in history to set foot on a celestial body beyond planet Earth, speaking the words that would become among the most quoted in human history. That's one small step for man. One giant leap for mankind, a phrase Armstrong maintained for the rest of his life he had intended to say. With the indefinite article, a before man, a small linguistic distinction that has been debated and analyzed by linguists and historians ever since, based on close analysis of the original audio recording without ever being fully and conclusively resolved. The scale of the global audience watching this moment unfold live remains, even by later standards, extraordinary, with broadcasts reaching an estimated 600 million viewers across dozens of countries, many of whom gathered around televisions in public squares, storefront windows, and community halls in nations that did not yet have widespread private television ownership, united, if only for a few hours, in watching the same grainy black and white images beam back across roughly 238,000 miles of empty space. Newspapers around the world ran the story as a singular banner headline the following day, and the moment was widely remembered afterward, alongside the assassination of President Kennedy years earlier, as one of the defining shared memories of an entire generation, a moment people recalled for the rest of their lives in vivid detail, including precisely where they had been and who they had been with when they watched a human being first walk upon the moon. Buzz Aldrin joined Armstrong on the surface roughly 19 minutes later, and the two astronauts spent approximately 2.5 hours outside the lunar module, conducting a range of activities that included collecting rock and soil samples for return to Earth, ultimately gathering nearly 50 pounds of lunar material, deploying a series of scientific instruments including a seismometer to measure moonquakes, and a retroreflector, still used by scientists today to precisely measure the distance between the Earth and Moon, using laser ranging, and planting an American flag, specially engineered with a horizontal rod, to make it appear to wave, despite the complete absence of any atmosphere or wind on the lunar surface. During this time, the astronauts also received a brief telephone call relayed from President Richard Nixon in the White House, who told them that as they spoke, all the people of this earth were truly one in their pride in what they had done, a moment that momentarily transformed the Cold War competition into a broader statement of shared human achievement. After completing their surface activities, Armstrong and Aldrin returned to the lunar module for a rest period before executing one of the mission's other critical and unforgiving maneuvers, the ascent from the lunar surface back into orbit to rendezvous with Michael Collins, still circling patiently above in the command module Columbia. This ascent depended entirely on the lunar module's single ascent engine functioning correctly, a piece of equipment that had, by engineering necessity, no backup, meaning any failure at this stage would have left Armstrong and Aldrin permanently stranded on the lunar surface with no possibility of rescue, a sobering reality that had led to serious contingency planning back on Earth, including an undelivered speech prepared for President Nixon in the event the astronauts became stranded and could not be recovered. The ascent engine performed flawlessly, and the lunar module successfully docked with the command module on July 21st, allowing Armstrong and Aldrin to rejoin Collins for the journey home. The command module Columbia splashed down safely in the Pacific Ocean on July 24th, 1969, and the three astronauts were recovered by the aircraft carrier USS Hornet, though not before spending, along with the lunar samples they had collected, a period of mandatory quarantine, a precaution NASA scientists had insisted upon out of an abundance of caution regarding the theoretical, though ultimately non-existent possibility that the astronauts might have been exposed to unknown lunar microorganisms during their time on the surface, a concern that reflected genuine scientific uncertainty at the time about the nature of an environment no human being had ever previously visited. The mission's success had an immediate and profound impact on the ongoing space race and Cold War competition between the United States and the Soviet Union, effectively settling in the eyes of much of the world the question of which superpower held the technological and scientific edge, a symbolic victory that Kennedy's original 1961 commitment had explicitly aimed to achieve, even though Kennedy himself, assassinated in Dallas in November 1963, did not live to see his own ambitious deadline met. The Soviet Union had in fact pursued its own competing crewed lunar landing program throughout the 1960s, centered on a massive rocket called the N-1, but the program suffered a series of catastrophic launch failures, including a spectacular explosion during an unmanned test in July 1969, just weeks before Apollo 11's own launch, and the Soviet lunar program was ultimately abandoned entirely in the early 1970s, a quiet and largely unacknowledged concession of defeat in the specific race to land humans on the moon. Apollo 11 was followed by 5 additional successful crewed lunar landing missions through the remainder of the Apollo program, concluding with Apollo 17 in December 1972, whose crew included geologist Harrison Schmitt, the only professional scientist among the 12 men who ultimately walked on the lunar surface across the entire Apollo program, a group that, to this day, remains the complete list of every human being who has ever set foot on a world beyond Earth. The Apollo program was ultimately curtailed earlier than originally envisioned, as public and congressional enthusiasm and the enormous budget the effort required gradually waned through the early 1970s amid shifting national priorities. the ongoing and costly war in Vietnam, and a growing sense among policymakers that the program's core Cold War political objective had already been decisively achieved. The technological legacy of the Apollo program extended in numerous and often underappreciated ways, well beyond the specific achievement of reaching the moon itself, driving significant advances in fields ranging from computing, since the Apollo guidance computer represented one of the earliest and most demanding real world applications of integrated circuit technology, to materials science, telecommunications, and medical monitoring equipment, innovations that, through subsequent commercial adaptation, found their way into countless aspects of everyday modern life in the decades that followed. Neil Armstrong, who died in 2012, remained throughout his life a notably private and reluctant public figure, despite his singular fame, rarely capitalizing commercially on his historic achievement and generally avoiding the spotlight in the decades after his flight. Buzz Aldrin, by contrast, became one of the program's most visible and outspoken public advocates for continued space exploration in the years and decades that followed. Michael Collins, who died in 2021, often reflected with characteristic humor on his own somewhat overlooked role as the astronaut who flew all the way to the moon and back without ever actually setting foot on its surface, a role he nonetheless described as personally fulfilling and essential to the mission's success in its own right. More than half a century later, Apollo 11 remains one of the most universally recognized achievements in human history, a moment frequently cited across many different nations and cultures as a rare instance of genuinely shared human accomplishment, transcending, if only briefly, the geopolitical rivalry that had originally driven the effort to achieve it. The famous photograph of Buzz Aldrin standing on the lunar surface, Armstrong's own reflection visible in his gold-plated visor, along with the recording of Armstrong's first words spoken from another world, remain among the most enduring and instantly recognizable images and sounds of the entire 20th century, a permanent testament to what a coordinated national effort, driven by ambition, scientific rigor, and no small amount of raw courage from the men willing to ride atop untested rockets into the unknown, proved capable of achieving when a nation, and its president, dared to commit to a goal that, at the moment it was first spoken aloud, seemed to many almost impossibly out of reach. And that is the story of Apollo 11, a mission born from Cold War rivalry, forged through years of sacrifice, failure, innovation, and extraordinary determination that ultimately became far more than a political victory. It became a victory for humanity itself. For one brief moment, the divisions of Earth seemed smaller than the world hanging above it, as millions looked up at the same moon and realized that the impossible had just become reality. The footprints left in the dust of the Sea of Tranquility remain there today, untouched by wind or rain, silent reminders of the day humanity first crossed the boundary between worlds. More than half a century later, they still challenge every generation with the same question. If we could reach the moon with the technology of 1969, what frontiers are waiting for us next? Thank you for joining me on the Retro Review, where we journey back through the moments that changed history forever. If you enjoyed this story, consider subscribing for more deep dives into the events, people, and discoveries that shaped our world. And until our next journey into the past, remember, history isn't just the story of where we've been. It's the map that shows us where we might go next.